adding vectors, subtracting vectors, multiplying a vector by a scalar. Okay, parallelogram rule for addition, adding vectors, we are going to use parallelogram rule, triangle rule. There is also trigonometric method, but it's not for this case this time. So, parallelogram rule for adding vectors. So the first step, what we are going to do. First, we draw the first vector, given its magnitude and direction. This is our first vector. Next, from the beginning of the first vector, this is beginning, this is the end, right? The arrow. From the beginning of the first vector, draw the second vector, also using both its magnitude and direction, okay? From the beginning of the first vector, we are drawing the second vector. Okay, so adding two diagonal, okay, completing diagonal, considering these two vectors as a side of the of parallelogram, and the diagonal of this parallelogram, it's gonna be the result sum of these two vectors. All right, so FR is equal F1 plus F2. Okay, and the beginning of the resulting vector coincide with the beginning of first and second vectors. Second rule, triangle rule. So the addition of vectors according to triangle rule is as follows. Draw the first vector using data about its length and direction. Okay? First one. And then from the end of the first vector, draw the second vector, also taking into account that it has and the size or length and the direction. So I'm starting second vector from the end of the first one. As you can see, parallelogram, I was starting from the beginning. The triangle, I'm starting from the end. And the resulting vector will be a vector whose beginning coincides with the beginning of the first vector, and end will coincide with the end of the second vector. Okay, so we get FR is equal F1 plus F2. Okay, next. The properties of addition, of vector additions, okay. Vector addition is commutative, okay. Which means vector A plus vector B is equal vector B plus vector A. Second, associative. which means A plus B. Remember, notation can be arrow, it can be just a line, plus C is equal A plus B plus C. Associative. Third one, vector A, if I add 0 vector, remember 0 vector has a length 0 and it's equal 0, is equal vector A. And lastly, if I add vector A to opposite direction, vector A to opposite direction, it's going to be equal to 0 vector. Okay, moving to subtraction now. Next, we are doing subtraction. Let's say if we want to do vector A, okay, do minus vector B is equal C. What I'm going to do, I can represent as A plus negative B, which means it's going to be opposite direction, right? And it's going to be equal C. Okay, so we have vector A okay, and I have the vector B, which is going like this. This is my A, this is my B. Now I need to use negative B, which means different, the opposite direction. So I am starting the beginning, coinciding the beginning of the vector B to the end of the vector A. And it's going to opposite direction. Parallel but opposite direction. Okay, and the this is going to be negative B, and the result is going to be result vector, resulting vector C. I'm connecting from the beginning of the vector A and to the end of vector B. This is going to be vector C. Okay, so you just use opposite direction and you will get subtraction. Okay, next is multiplying vectors by numbers, which means scalar values geometrically, because we cannot multiply vector by vector. So we are multiplying vectors only by numbers. When using vectors, real numbers are referred to as scalars. Okay? Scalars are quantities that have only magnitude. What can be example of scalar quantity? Let's say it can be temperature, it can be speed, it can be time. It doesn't have direction. Okay. Now let's see how we're going to multiply a vector by scalar value. Okay. If vector A we want to multiply by scalar value lambda, let's say lambda times vector A, it's equal vector B, right? then in this case, the magnitude of vector B, it's going to be equal absolute value of lambda. Why we are not saying magnitude of lambda? Because lambda is not a vector, it's a scalar value. That's why the symbol, we take as an absolute value, and then times by magnitude of vector A. Okay, so this is number 1 case. Number 2 case, if lambda is greater than 0, since we have absolute value, so we are going to look lambda greater than 0, lambda less than 0. So if lambda greater than 0, then vector A and vector B have same direction. Okay? Okay, if lambda is less than 0, then A and B have opposite direction. Okay? All right, and if lambda is equal 0, clean this number too, since we are looking cases. If lambda is equals 0, then vector A is equal to vector 0, which means lambda times vector A is equal vector 0. Okay, now let's look at properties of the multiplication vector and scalar value. For any vectors A and B, we can write down, put here properties. So property number 1, 1 times vector A is equal vector A. -1 scalar value, this is lambda in our case, times vector A is equal negative vector A, opposite direction, right? Number 2, if we have alpha times beta times vector A, this is going to be equal, I can write down, alpha beta multiply, both of them scalar, times vector B. Number 3, alpha plus beta multiply by A vector is equal alpha vector A plus beta vector A. Familiar property, right? We already know that. This property. And the fourth property, alpha times vector A plus vector B is equal. So you can multiply vector by sum of scalar values, and you can multiply scalar value by sum of 2 vectors. It's going to be equal alpha vector A plus alpha vector B. Okay, and the other thing I would like to mention that 2 vectors A and B, vector A and vector B, where vector A is not equal vector 0, they are collinear only and only when exists some number lambda, where vector B is equal lambda times A. Okay, then vector A and vector B will be considered as collinear vectors. Okay, let me explain this multiplication also. Here we have practically our lambda here is 2, right? This is equal to times vector A, lambda A, okay? And here we have negative 2/3 times vector A, which means it's going opposite direction, right? Of vector A, and 2/3 times shorter, 2/3 portion of vector A. Okay, let's practice a little bit. Let's solve a couple of cases of adding and subtracting and multiplying vectors. So this is what we have. Example. This is vector V. Okay, here we have vector, let me use a different color. We have vector W, and we have vector U. Let me do this way. Vector U. Let me rewrite W one more time. All right. I would like to make it a little bit longer. Okay. Okay, W. And vector U. Okay. Good enough. So, first one, we need to do vector V minus vector W, which is same thing as a V plus opposite direction of W, right? So I'm going to use triangle method. Okay. So I'm taking my vector V, okay, running parallel in the same magnitude. Don't judge me if a little bit not precisely parallel or length is not the same. Next, adding negative W. So since W goes down, that means negative W will gonna go parallel but up, right? Here it is. This is negative W. This is V. Okay, and V minus W is going to be, it will connect the beginning of V to the end of the negative W vectors. There we go. So this is going to be V minus W. Okay, this is first case. Next case B, this is A. Let's do case B. So I'm going to do, let's say, free V plus 2W. Okay. 3 times vector V. Oh God, give me good luck. So, all right, not precisely 3 times, but assuming 3 times vector V. Next, 2W. Since same direction, so I'm providing parallel from the end of the vector free V. Okay, providing twice as longer size. Okay, this is 2W. Okay, and the result is going to be, it's going to connect beginning of free V since addition. It's connecting beginning of the first the vector and connect to with the end of the second vector. So this is going to be free V plus 2W. Okay. And the next one, question number C. Let's say we have 2V minus W plus U. Longer operation. So first I'm going to take twice a vector V. So first let's take vector twice as long of vector V. One more time. Okay. Next I am going to do add opposite direction of W, right? This is going to be negative W. And adding to it a vector U. So the result is going to be connecting from this end, beginning of the, oh, I didn't write down. Let me write down. This is 2W, I mean 2V. This one is negative W, right? Opposite direction. And this is our U. Let me move a little bit down. Okay. And lastly, we are going to connect, let me take this color, the beginning of V to the end of U vector. And this is going to be 2V minus W plus U. Okay, Okie dokie. See you again. I will continue with the vectors. There is a lot of topics to cover in vector. Slowly but surely we will move ahead. All right.